Welcome, first graders, to your second day of school. Welcome to the STEM Environmental Education Center, and a special welcome to Thomas Marsalis, first graders from the Elementary STEAM Academy. We are so excited to have you with us today. If you are watching this and have not registered for this field trip yet, you can still register by going to www.tiny.cc/EEC to register yourself or your class for this field trip. Today, we are going to discuss classifying objects. So during this virtual field trip, students will discover that objects have properties and patterns. We're going to explore the properties of size, texture, shape, color, and weight. And when we do science investigations, we usually use some tools, and today we are going to use three tools. We're going to use a ribbon, a hand lens, and a balance. While you're watching today's field trip, if you have any questions, do not raise your hand because we cannot see or hear you, but you can ask us questions. You can do that by going to www.tiny.cc/EEC-question-answer, and you can fill out a short form to submit your questions to us, and we will get to those during the field trip, or at least during the last 10 minutes of the field trip. You can ask as many questions as you like, and we will do our best to answer all of them. So without further ado, I'm going to stop sharing my screen here and hand it over to Mr. Monroe, who will get us started with the property of size.
Good morning, good morning. My name is Mr. Monroe, and my part of this virtual field trip is to deal with the property of size. You know, when we talk about a property, we're talking property of matter. We're talking about how an object looks, feels, or acts. Today, we're going to be looking at some different size animals. I have several animals that are going to help me get this concept over to you, dealing with size. The words that we're going to focus on today are larger and smaller. My first animal friend that I'm going to be getting out is a Cicada tortoise. Now, this tortoise can live to be very old, well over 100 years, and it can weigh well over 100 pounds by the time that he reaches his end of his lifespan. Students, the tortoise that I'm going to get out, we have a name for that tortoise. His name is Michelangelo. You know, we have lots of animals that are found right here in Texas, but this tortoise did not come from Texas, nor did it come from North America. The origin of this species of turtle is the continent of Africa. The Cicada tortoise is considered to be one of the largest tortoises found in the world today. Let me get Michelangelo out. This is Michelangelo. You can see he is quite large. Another common name for this tortoise, they're often referred to as the African spurred tortoise. Now, we got Michelangelo about 10 years ago. When we got him, he was a lot smaller than this. In fact, the family that brought him in, they were looking for a home for him simply because they found him in the backyard. Evidently, he had escaped from someone else, and they didn't know what quite to do with him because they had other pets. And I guess with the other pets and then Michelangelo's appetite, they couldn't afford the food bill. When they found Michelangelo, they gave him the name simply because they found orange paint on his shell. And you can see there is no evidence of the orange paint now because he has grown quite a bit. Cicada tortoises, they can make an excellent pet if you keep them healthy and happy. Things that you need to take into consideration if you do have one is the fact that their lifespan is so long, and conditions, you have to treat them right, especially with their diet. Basically, they are a vegetarian or a herbivore. Okay, Michelangelo is quite large, right? Boy, he's curious. He's really looking around. I'm going to put Michelangelo down and get another one of my friends out so we can compare the size. Now, here is another turtle. This turtle is called a three-toed box turtle. And one of the reasons that, or several of the reasons that they have that name, I'm kind of guessing at this, is the fact that if this turtle was to become afraid or nervous, it could close itself up completely in its shell. His little feet could go in, his head could go in, his little stubby tail back here could go in, completely inside the shell for protection. Well, the other part of the name, the three toes, simply probably comes from the fact that each of the back feet have three toes on each foot. So it's a three-toed box turtle. This is one species of turtle that you can tell whether it's a girl or boy by simply looking at the eyes. The black dot that's in the center, that's called a pupil, okay? There is a ring around that black dot, and the ring in this case is a goldish or brownish color. So you know what that tells us? This is a girl, a female. Now, Michelangelo's much larger than this turtle. In fact, this turtle has a name also. Her name is Teresa. This is Teresa the turtle. Now, Michelangelo is a great deal larger than Teresa. Michelangelo is about 20 years old, so he's got a long ways to go. Teresa is somewhere between maybe 12 and 15 years old. And she can live to be 100 years old too. Boy, turtles and tortoises can live a very long time, guys. I want you to remember that. So, Michelangelo is larger. Teresa is smaller. I've got another little friend that I want to show you. And this turtle's name is Tiny. You see Tiny? Tiny is also a three-toed box turtle. Now, Teresa, 12 to 15 years old. This one maybe 5 years old. So this one's got a ways to go. If we look very closely at this one's eyes, we see the pupil, we see the ring around the pupil. It's a goldish and a brown color, so this is also a female. So Tiny is a girl also. And she does have three toes on each of her back feet, okay? So Tiny is smaller than Teresa. Teresa is smaller than Michelangelo. Michelangelo is larger than Teresa, and Teresa is larger than Tiny. You know, you walk around your house and maybe walk out in your yard, walk over in the forest. If we were taking you on a nature trail hike today, you would see things that are large, you would see things that are small, and sometimes you can run into objects that you can't figure out whether it's larger or smaller than the other object. So then you have to use a scientific tool to take a measurement, right? One of the most common tools that we use is called a yardstick or a ruler, okay? Or sometimes even a long strip called a measuring tape. But today we are not using that because sometimes you don't have those tools around. So basically what we're going to use today is a ribbon, a blue ribbon. Now, I'm going to get Michelangelo out and we're going to do some measuring, okay? Oh, here's old Michelangelo. He's up. Everybody can see him, I hope. And we're going to take this tape or this ribbon and we're going to put one end of it on the front end of the shell and the other end on the back part of the shell at the very end. And we're going to make a mark, not on the shell, but on the ribbon, okay? And that's going to give us the length. That mark is right there at the end, okay? Michelangelo is probably wondering, what is he doing with me? But I'm going to put him back. Boy, he's a big guy, isn't he? Now, sometimes there is a problem. We might forget about the mark or how long we actually measured it. So a lot of scientists, when they get data or information, they record it some kind of way. And we're going to record ours You can do this on a piece of paper if you're measuring objects around your house. But I'm going to use this wet board. And I'm going to use different colors for each turtle. We're going to use black for Michelangelo. I'm going to go up and make a mark at the very beginning. That's Michelangelo's mark right there. This is the mark that was marked at the end of his shell right here. And then I'm going to take and I'm going to draw a black line, shade that out so everybody can see that. That's how long Michelangelo's shell is, okay? Now, I'm going to get Teresa out. We're going to do the same thing with Teresa. Okay. There's, oops, she's trying to crawl away. There's Teresa's shell. I'm going to put one end at the, right there. And then I'm going to put that right there at the very end. And I'm going to mark where her back of the shell ends, right there. I'm going to put her back. Then I'm going to make Teresa's color blue. We're going to use blue. You guys can use different colors to determine what object that you're marking or recording. I'm going to make her color blue. Start right there, and then we're going to put it right there. We're going to draw a line there. Well, we can see that Michelangelo's shell is a lot longer than Teresa's shell. Well, next, guess what? We're going to get Tiny out. What do you think? You think Tiny shell is going to be a little smaller? Let's see. I'm going to put the end of the ribbon right there, just like we did the others. And I'm going to put a mark right at the very end, not on her shell. We don't mark on the shell, but on the ribbon. And I'm going to put her back. And I'm going to use red for Tiny. There. And right there. Okay. Tiny is smaller than Teresa. Teresa is larger than Tiny. Teresa is smaller than Michelangelo, but yet she's larger than Tiny. Michelangelo is larger than Teresa, and Teresa is smaller than Michelangelo. Now we can actually see how we compare sizes, right? And we also record it. Now, if any of you students have questions, I'm going to turn it back over to Mr. Broughton so he can answer those questions for you. Thanks for the time that you have given me.
Yes, we did have one question, which is, what is the difference between a turtle and a tortoise? And a tortoise is a kind of turtle, but what makes a tortoise is that tortoises only eat plants. Some turtles do eat meat, like a snapping turtle, but tortoises are only herbivores. One other difference is that tortoises cannot swim, and some turtles can swim. In fact, some turtles spend most of their life in the water, but a tortoise does not. It likes a little bit of water, but since it can't swim, it definitely will not try to go into a pond or lake or ocean or anything like that. All right, I'm going to turn it over to Mrs. Fuller, who will discuss the properties of texture.
Good morning, first grade. My name is Mrs. Fuller. We'll be covering TEKS 1.5, matter and energy. Objects have properties and patterns. We can observe and record properties of objects. Now, when we observe, we use our five senses, our senses of vision or seeing, smelling, tasting, hearing, and touch. Now, in this segment, we're going to talk about texture. Texture is how something looks or how it feels. So we're going to start with smooth and rough. This is a feather. You only find feathers on birds. This is my chicken, Lauren Araucana. She's from South America. She lays green eggs, and she can fly. She can fly a little bit. So she does have flight feathers, these big feathers that are smooth. The smooth feathers help her push against the air so that she can fly. Also, on her body, she has contour feathers. These are body feathers that make her very smooth. These smooth body feathers help her glide through the air, help her move through the air smoothly. Now, when we use our sense of vision and our sense of touch to determine texture, we can also use a science tool that will help us. This science tool is a hand lens, and it will magnify the things you look at. By using this hand lens, I can see that Lauren Araucana's feathers are very smooth. That's the texture of the feathers. I'm going to put her down, and I'm going to show you an animal that has a skin that is rough. It's very bumpy. This is my gecko. His name is Peanut. Can you see his sweet face? He's a sweet boy, and he has very bumpy skin. His skin is rough. I can tell by feeling it that it's rough. I can tell by looking at it that Peanut has rough skin, and I can use a hand lens to magnify the bumps on his body to know that he has very rough skin. I'm going to put Peanut back. So we've looked at smooth and rough. Now let's look at soft and hard. This is a Bobcat Pelt. Texas has 5 different kinds of wild cats. We have bobcats, pumas, margays, ocelots, and jaguarundis. The last 4 are very rare. You will rarely see them. Even though the bobcat is a common animal in Texas, most Texans never see a live one because they're extremely shy. They don't like being seen. But their pelt is very, very smooth. Now, a pelt is the skin of a mammal that still has the fur on it. So we know the bobcat is a mammal because he has fur or hair. I can tell by touching that he has soft fur. I can tell by looking that he has soft fur. Let me show you the soft fur on. Can you see that? How beautiful that is? The soft fur on the bobcat. But I can also use my hand lens, my science tool, to look at the soft fur. See all those hairs in this fur. See how soft it is. This soft fur helps the bobcat be warm in the winter time. Now that was soft. Let's look at hard. I'm going to show you a turtle shell. But if you will look, you will see no one is at home. This turtle is not alive. In order to be alive, a turtle has to be inside a shell. He cannot live outside the shell. His backbone is inside the top part of the shell. So I can tell by looking, the shell is hard. I can take my hand lens and examine it. Oh yes, that's a hard shell. I can even touch it and tell that the shell is hard. I can also make a sound with my fingernails that tell me the turtle shell is hard. Now the turtle shell is to protect the turtle from predators. The hard shell is hard for predators to break. So here is a live turtle. His name is Terrence. Say hi, Terrence. Terrence is also a 3-toed box turtle, and Terrence is alive. He's inside his shell, and he's alive. He has a hard shell. So the bobcat had a soft fur. The turtle has a hard shell. Those are 2 different kinds of textures. Okay, the next texture we're going to look at are textures on rocks. We're going to look at the texture of coarse and the texture of fine. The first one we're going to look at is coarse means large and fine means tiny. So this is a rock. It's called pudding stone. It's full of big crystals and big pieces of rock. I'm going to put it up here so you can see those big pieces. I can also look at it with my hand lens. Oh yes, it's got very big crystals and very big pieces in it. It's cemented together by Mother Nature. This is a sedimentary rock called pudding stone, and it has a coarse texture. It has a coarse grain. I can even tell by feeling it's got real big pieces in it. Coarse. The next one is fine. Fine means tiny. This is a piece of obsidian. It's got a very fine grain, very, very tiny crystals. So tiny, I can't see them with my eye. I can't even see them with a hand lens. They're too fine, and it's too tiny. This obsidian has a fine grain or a fine texture. Okay, and I'm going to turn it over to Mr. Monroe. I'm going to turn it over to Mr. Broughton in case you have any questions about texture. Thank you so much.
And there was one question about texture, which is, what are all the different textures? And there are too many to name, because remember, everything that you see and everything that you can touch has a texture. So if you think about all the things you've seen in your life, all the things you've touched in your life, that would be a lot of different textures. I will show one as an example. So I'm going to share my screen with you here real quick. And this one's always been kind of interesting to me. This is a picture of a wall, and you can see that it has a texture. And the name of this texture is orange peel, because whoever came up with this texture for walls and houses and apartments decided that that looked and felt kind of like the peel of an orange, so they call that orange peel. And that is a texture you've probably seen, maybe even in your school. But it's kind of an interesting one to me. It's not always just soft and smooth, but there's interesting names out there. You'll just have to explore those on your own. So now I'm going to turn it over to Miss Nash, and she's going to talk about sizes, shapes, and colors of leaves.
Hello, first grade. Welcome to my classroom. My name is Miss Nash, and today we're going to be talking about shapes and colors. For most equal colors. And we're going to be looking at leaves. And you might think to yourself, Miss Nash, leaves are all green. They're all the same color. And they're all leaf shaped. And a lot of them are green. A lot of them have that kind of typical leaf shape, right? But not all of them. And if you have a crayon or a pencil and I ask you to draw me a leaf, you might draw something that looks like that. That would be fine. And then if I ask you to color it for me, you might color it green. And if I look outside right now, most of the leaves are green. But then if we wait a while, in a couple weeks, that leaf might turn yellow, or it might turn orange. It might turn even red. And then it's going to fall off the tree because winter is coming, and it's going to be brown. And then all winter long, the tree won't have any leaves until spring comes again and they grow again. But these new ones are going to be green again, but a different green, a kind of light spring green. So the same tree can have different colors during the year. It's a fun thing to start noticing. So you can go to the park or the schoolyard and you can find a tree you like, especially like, and you can start noticing it every time you go. And that way you can start to be a plant scientist. The great thing about being a plant scientist is that plants can't run away. And so that tree will be there tomorrow, next week, next month, next year, 100 years from now. And you can do a lot of interesting observations on that tree. Now, I really like plants. And I went for a walk in my garden and I found a plant I think liked me too. It had made me a lovely Valentine. This big green heart. It's kind of soft and fuzzy. Smells good. Oh, Santa. And then I went walking and I found another heart from a red tree. This one has pretty pink flowers in the spring. And I think somebody else liked this one too. You see all the holes in the leaves? What do you think made those holes? A caterpillar. I think so too. I found Another heart. There are lots of heart shapes out there. A little heart. So you can go to the park and see if you can find some heart-shaped leaves. There are a lot of heart shapes out there. Then I have another interesting one here. This one's called angel wing. And somebody thought it was like an angel's wing. It's kind of a silvery gray color, isn't that pretty? It has those dark green lines in it. Those lines are called veins. Now we have veins in our body too. You know what's in our veins? Blood. That means that plants have blood, a leaf has blood? Well, no, it's a liquid, a mixture of the water sucked up by the roots and the sugar that the leaf makes. But a fun thing to look at with your hand lens are all those different veins. And you can notice how they get smaller and smaller as they go out through the leaf. Okay. And you can also notice different patterns of veins. So some make kind of like a tree shape, okay, with the veins. It looks like a tree. And you can take a leaf, you can get a grown-up maybe to help you, take a piece of paper, fold it over, put the leaf on one side, fold it over, take your crayon, and you can, with your crayon, you can rub over the top of the paper, and you can see the shape of that leaf. And then you can get another leaf and compare the different shapes. You'll get an outline of that leaf by rubbing your crayon all over the paper. Like that. And I get the shape of my leaf. And I can get other leaves and find different shapes, all different kinds of shapes that I can record by just a crayon and a piece of paper. So that's a really fun thing to do, a way to study your different leaves. So some are silvery gray. That helps them live where it's kind of hot. And some are long and skinny. This long, skinny one is a grass. And if you feel it, be careful because it's kind of rough. You can look with your hand lens at the very edge of it. It's got little teeth on it. That discourages any rabbit from eating it. Here's another long one, a long fat one. And somebody was eating on this one too. And this one's cool because the veins, and you see the veins are long straight lines. So again, a different kind of veins. Other colors you can look at, here's a yellow one with green in the middle. It's kind of thick. Here's a little fat one, an interesting shape, a spoon shape. This one fell off. You can see how fat it is. Really thick and stiff. Okay. It helps it survive without much water. Here's a cool shape, like a feather. Okay, like the feather Mrs. Fuller showed you. Only this one came from a plant. And it's a fern. And we don't see many of these around in our forest because there's not enough rain for this kind of plant. They need extra water. Their leaves are very thin when you feel them, and they dry out really quickly. Purple leaves. Purple ones, aren't those pretty? And then another purple one. It's really interesting because it's more purple on the underside and kind of roughly around the edges. Oftentimes the top of a leaf and the underside are quite different. So this one is shiny green on top, and then underneath it's silvery, and it feels different too. And again, another fun thing to observe is those differences, the texture, like Mrs. Fuller was talking about, on one leaf can be different on the top and the bottom. So there's so many things to learn and discover just by observing and making maybe a little collection of leaves. Okay. So I encourage you to go do that. And now we're going to let Mr. Broughton answer any questions that you have.
And we did have one question, which is, why are leaves different shapes and sizes? And there are different reasons for leaves being different shapes and sizes, but in general, if a tree or a plant grows somewhere where it's getting lots of water, like in a rainforest, the leaves are going to be bigger. If it grows somewhere where it's not getting as much rain or water, it's going to be a little bit smaller. And then for shapes, I'm going to share my screen here with you and show you something about shapes of leaves. Here we go. If you see a leaf that has a smooth edge to it, that tells you that it probably grows somewhere where it's a little bit warmer. If you see a leaf that has these toothy edge to it, like that kind of toothy shape, that tells you that it probably grows where it's someplace that's a little bit colder. And the reason trees that grow in colder areas have these toothy shapes to them is that it helps them make their food faster, because summer doesn't last as long since it's colder there. So they've got to make their food as fast as they can before winter comes again. This tree doesn't have to worry about winter coming so fast, because maybe it grows in a rainforest where winter never comes. It's just rainy and dry seasons, and it can take its time making its food. This leaf also doesn't lose as much water. A leaf like this will lose more. So it's a trade-off as far as the shape goes and why it helps that plant. So that's kind of a quick explanation of why leaves are different shapes and sizes. And now I'm going to turn it over to Miss Ramirez, who will discuss weight.
Hello, first grade. My name is Miss Ramirez, and today we're going to learn about the property of matter called mass. So can you guys say that word with me? Mass. To demonstrate the property of mass, we're going to look at two objects and we're going to compare their mass. So essentially, mass is just telling us if an object is heavier or lighter. So the first object we're going to look at today are some eggs. These eggs were laid by my pet chicken, Pepper, and we're going to compare the mass of these eggs to that of my adult chicken, Pepper. So let me go ahead and grab her out of her little holding box. This is Pepper. She is an adult blue silky chicken. She is a girl. They get their name blue silky because they have very soft feathers and they have these blue skin around their ears. So using your senses of sight, make some observations about the properties that you notice between Pepper, the adult chicken, and her eggs. Also, make a prediction. Which one do you think has more mass, and how can you tell? Now, luckily, because I'm able to hold them, I can use my sense of feeling to lift them up, and just by feeling, I know that Pepper, the adult chicken, is indeed heavier than her eggs. Now, if I wanted to be a real scientist, I could use a science tool called a balance. Now I'm going to show you what a balance looks like, and then we're going to use our balance to compare the masses of two different things. So this is a balance, and it can help us compare the masses of two things, so whether an object is going to be lighter or heavier than something else. And to use our balance, we're going to look at two more objects. Our first one is another living thing. It is a Madagascar hissing cockroach. They get their name because when they're scared, they make a loud hissing sound like a snake. And we're going to compare Oscar to our limestone rock. So y'all learned about properties earlier with the other teachers. Make some quick observations about the properties that you notice. Maybe think about their textures, their colors, their size, and also make a prediction. Which one do you think has more mass and why? Oops. He almost fell there. I'm going to move over to the back table. Oh, I think you can hear him hissing. We're going to move over to the back table, and we're going to use our balance that's already set up, and we're going to compare their masses. Oscar is being super active today. The way this is going to work, I'm going to put Oscar on one end of the balance and my limestone rock in the other, and we're gonna compare their masses. So make a prediction as to which one you think might be heavier and why, and also make a prediction, what do you think is gonna happen with our balance? So I'm gonna gently place Oscar in one end, and I'm gonna place my limestone in the other. So what did you guys see? And which one do you think is heavier? Now, the way this works, I know that the object that is heavier is going to be on the downside. So this lets us know that the limestone is heavier than the cockroach because it's on the downside. The cockroach is lighter, and we know that it's lighter because it's on the upside. Now, here's something important to know. Hopefully, when I was asking you guys to observe these two, hopefully you guys noticed that Oscar is actually bigger than the limestone. So what that tells us is just because something is bigger than something else doesn't always make it heavier. So as a scientist, it's always important to either pick the objects up if it's safe and possible, or use a balance to help you compare those masses. So just by looking at something will not always tell you if something's going to be light or heavy. So you always have to compare and measure. Now, this is our science balance. If you don't have your own balance at home, you can make your own balance at home using some simple tools. You can have an adult help you. All you'll need is a hanger, some string, and 2 cups. We're going to use our homemade balance to compare the masses of 3 different objects. So we have a beautiful peacock feather from a male peacock. They're beautiful in color. We have iron pyrite, often called fool's gold because it looks like gold, but unfortunately it's not real. And then we have our wonderful seashell. So make a prediction. Which of these 3 objects do you think is the lightest? And which one do you think is the heaviest? And think, why did I place them in that order? So we're actually going to compare and measure these using our balance. We're going to start off with our peacock feather. We're going to put it in on one end, and we're going to compare it to our iron pyrite. So make your prediction really quick. Which one do you think is heavier? What do you think is going to happen, and why? So hopefully you guys were able to see that our iron pyrite is on the downside. So that lets us know that it is heavier than our feather. So now let's compare our feather with the seashell. Go ahead and make your prediction on which one is going to be heavier and why. And then we'll see what happens. So again, we noticed that our seashell is heavier because it's on the downside. So these 2 trials let us know that the feather is the lightest of the 3 objects. So now all we have left to do is to compare the last 2 objects. So we'll put our seashell on one end, our iron pyrite on the other, and we'll see what happens. So you'll notice the iron pyrite is on the downside, so it is heavier. The seashell is on the upside, so it is lighter. So using a balance is a quick and easy way to help us compare the masses between objects. So if I were to ask you guys to put these 3 objects in order from lightest to heaviest, how would you arrange it? So you could say our feather is the lightest, our seashell is the second lightest, and our iron pyrite is the heaviest. So to review, we're going to review some vocabulary words really quick with our anchor chart. With Mr. Monroe, you guys learned that matter is simply anything that takes up space. So we are all examples of matter. We take up space. In this segment, we learned about the property of matter called mass. And all masses is just the amount of matter that makes up an object. And we can compare the masses of objects using a simple balance. So if we look at our balance on our chart, we are comparing the mass of a grape and an apple. So if we look at the diagram, the grape is on the upside, and that lets us know that it is lighter. The apple is on the downside, and that lets us know that it is heavier. And again, size does not always tell us if something is going to be heavy or light. So that's why it's important that we pick them up if possible, or we use a balance to help us determine. So before you guys go, I have 2 tasks for you guys. The first one is an at-home challenge. I want you to see if you can find 5 things. So 5 things around your house and put them in order from the lightest to the heaviest. After you do that, I also have a reflection question for you guys, and I want you to think, how does math relate to you? So why is it important to learn about math, or how do you use the concepts of heavier or lighter at home or in your everyday lives? And that is all I have for you guys today on math and determining whether something is heavy or light. So I'm going to go ahead and pass it back to Mr. Broughton, and he's going to be more than happy to answer any questions that you might have.
Thank you, Mr. Ramirez. And we did have one question, which is, how do you measure mass using a pan balance? And I'm going to attempt to show you that virtually using a website here. There it is. And so here's my pan balance. And if I put one of these objects, like let me try a cupcake on one side, you can see that it went down because a cupcake is heavier than nothing. But then down below here are some gram pieces. You measure mass in grams. So there's 5 grams, 4 grams, 3 grams, 2 grams, and 1 gram. And I'm going to try something over here and see if it balanced. And it's not quite balanced. You can see that 5 grams is still a little bit higher than the cupcake. So the cupcake has a mass of more than 5 grams. Let me try adding 2 more grams to this. Nope, that was too many, because now the cupcake is higher than these 7 grams. So if I put 2 back and try just 1 gram, there it is. It's balanced. So the cupcake has a mass of 6 grams is what we could say. Let's try something else. Let's try an animal. How about a frog? So there's the frog on our balance. You can see the frog is heavier than nothing. Let's try adding 5 grams to the balance. The frog is heavier than 5 grams. Let's try 5 more. That looks like a pretty big frog. The frog is still heavier than 10 grams. Let's try another 5. Wow, that frog is still heavier than 15 grams. Even another 5. So the frog is heavier than 20 grams. Let's try another 5. Oh, that was too much. Now you can see that 25 grams is heavier than the frog. So I'm going to take 5 back. Let me scoot that over so you can see it. And let's try just adding 4 grams. And there it is. It's balanced. So this frog has a mass of 5, 10, 15, 20 plus 4 is 24 grams. So that is how you measure mass using a balance. Got one last thing to go over with you for today. Let me get this pulled up here. So during this field trip, we explored the properties of size. We talked about bigger or smaller. Texture, we talked about hard or soft, rough or smooth, and coarse or fine. We saw different shapes and different colors, especially when it comes to leaves. And weight, if something is heavier or lighter. You can use a pan balance to tell that. And we did use a ribbon to measure the length of those turtle and tortoise shells, a hand lens to observe different objects, and that balance to see if something was heavier or lighter. And we thank you so much for joining us today. We do want your feedback on today's trip. You can let us know how we did by going to www.tiny.cc/EEC feedback and giving us feedback on today's trip. And we hope to see you again in about a few weeks. Our upcoming field trip for first grade is going to be about heating and cooling matter. So thank you very much and enjoy the rest of your second day of school. We hope you have a good one. Bye-bye.